Hello, my name is Khaled Pashar, and in this video, I am going to demonstrate my project GraphBench. GraphBench is a graph database like benchmarking and performance analysis platform built specifically around the CognoDB. The goal of the project is to make a graph database performance testing and reproducing measurable and easier to analyze. Along with the demonstrated benchmark matrix, I also add a AI assistant uh, analysis layer using hybrid BM25 and vector retrieval with Groq model. The main problem I want to solve that the graph database branching is often done as a collection of script, making it the difficult to consistently run the workloads, compare results, and understand why performance change. GraphBench address this by providing a complete workflow. I can inspect uh, data set, run control, benchmark, workload, like collecting the latency and through the metrics and uh, latency and work through the matrix and compare the benchmark, run, generate report and finalize, use AI analysis, the benchmark evidence, etc. The important point here is that a benchmark measurements themselves are deterministically application data. AI is a use for interpretations, not for generate a individual benchmark are measurable. At the architecture level, a application has four major layers. First is the wave control center, which provide the user interface. Second is the benchmark and the data set layer, which execute the control workload. The third is the CognoDB, which is the only database used by the project. I am using Neo 4J driver only as a client driver for connecting to CognoDB. Neo 4J itself, it not used for the database, right? The fourth layer is the AI analysis pipeline. This one, the statically analyzer. This separation is intentional because I don't want to language model to directly determine the benchmark results. Let's start with dataset. For the demonstrate, I am using a Wikibot graph dataset. This one. The dataset pipeline validate the input before it is used for the benchmarking. This is important because invalid or inconsistent graph data can produce the misleading branch results. If you are, if you are, you if yeah, like like okay, after the validation, the data set can be used by a benchmark engine. Now I will move to actual benchmark workflow. This benchmark should include a graph traversal and lookup workloads, as well as mixed workload with configurable concurrency. The branch mark separates warm up and interaction from the measured like iterations. This helped reduce the effect of the initial connection and runtime warm-up behavior. For each benchmark, I collect latency, throughput, and error information. Have we can they inspect the individual marks run? Like you can anyone you if you want you can run and change the warm up, accept the instruction, like instruction and everything you can change yourself. Actually, I already run, so I'm not running because it's take lots of time, right? So if you want to check, you can check your own. The main metrics I focus on on are um, P50 latency and P95 latency through our QPS and error rate. Uh, P50 give us a typical latency while P95 help us understand the solo tail uh, tail of our the workload. Instead of looking at the individual number isolation and the application can compare multiple benchmark run, right? See, instead of looking at individual number in the isolation, the application can compare multiple benchmark runs. These things. Now the report. The report section convert the raw benchmark output into a more readable performance summary. The makes it easier to identify performance change across workload or like concurrency level, right? You can see the report also preserve the benchmark methodology and context because performance number without methodology can easily be misleading. Now, I will demonstrate the AI assistant analysis. One problem I encountered during development was that sending complete benchmark JSON file directly to the language model could exceed the model context or token limit. To solve this, I complete a retrieval layer before calling the model. BM25 provide a lexical like VM25 provide lexical relevance while vector similarity provide a sensitive relevance. The two signals are combined into a hybrid ranking. Only the most relevant evidence is sent to the language model. The AI provide is the access through the OpenAI compatible API exposed by Groq. This keeps the AI context bounded and reduce unnecessary token reuse. See, the model receive a selective benchmark evidence and produce an interpretations of the observed performance. The AI is not allowed to invent a benchmark measurement. It must base it a conclusion on the retrieve the benchmark evidence. This separation between the deterministic measurement and problematic interpretations is one of the key design discussions in the project. The application is deployed as a production web service on render. Okay, and the same application that demonstrate locally is available deploy application you cannot, because this project completely based on CLI, right? This project is completely CLI based. So yeah, I just macro that UI is better to understand about the project. So that's why I create the UI also. But this project is completely based on CLI, because this project only backend project. The deploy separation, the web application from the environment specification, the config is such as CognoDB and Groq credentials. You will set according to you. Uh, Sensitive configurations such as the database, a credential, Groq, API key, and administrative controls are handled through the environment a variable rather than being hard coded into the application. See, you need to add, uh, you have your admin token. So this is common token. Actually, you can create your own if you are like, uh, if you are taking the repo, like you have like if you have fork my repo and you can take pull from my repo. So you will get you can create your own env file, environmental file, and there you can set your own. I can here I am just written as a if I'm talking about this, so I'm just like calendar hyphen Prashad. If you want to see, I just uh, see this is currently. If you want to use, then you can use, right? If you want to use, you can use this one, right? There's calendar Prashad, and yeah, okay, fine. Everything is fine. You can click on save button. Now you are able to click all like things like run like benchmarks. If you run benchmark, you can coming here and you can collecting the footprints and test CognoDB if you want to test, etc. You can easily you are able to, right? So to summarize, the GraphBench provide an end-to-end workflow for a graph. Uh, mm, Database, the graph database, like benchmarking. It combines a like reproducible benchmark execution, performance metrics, result comparison, like comparison and reporting and AI assistant analysis. The database layer use CognoDB with Neo4j driver use only as a driver. For AI analysis, I use a hybrid BM25 and vector retrieval approach before sending the bounded evidence to Groq. The application is also deployed as a production web application. Thank you for watching. The source code, documentation, and the live demo are available through the submission, right? Like on your description, or you can see my you are able to see on my uh, video description also, right?